Doing Leetcode problem 637, average of levels in binary tree. It says it's a Leetcode easy. I think it's more of a medium problem, but again, that's just me, and most problems are difficult. But given the root of a binary tree, return the average value of the nodes on each level in the form of an array. Answers within 10 to the negative fifth power of the actual answer will be accepted. So first example, this is the answer, and they explain it here pretty well. They want just the average of the nodes at each level, right? So first level, there's only 3. Average of 3 is just 3. Average of 9 and 20 between 2 nodes is 14.5. Same with 15 plus 7 divided by 2 gets you 11. Second example is the same tree, pretty much, but if you notice here, 15 and 7 are not the children of 20, but the children of 9. It will get you the same answer because we're just looking for the average. So, how are we going to do this problem? We're going to do a level order traversal. We'll go level by level and do a BFS. And we'll just take the average by calculating the total sum of the nodes and then divide by the size. And what size is going to be is just the number of nodes at each level. So let's get in the code, and then hopefully this makes sense while we do it, right? So first off, if what they give us is a null value for the root, we'll just return 0 because that's the average of something that's null, right? There's nothing. I'm going to create a queue here, and I'm going to append the first thing into the queue. This condition here, this looping condition, is while the length of the queue is greater than 0, meaning while our queue is not empty, right, the queue is going to keep up the tree as we traverse down it, right? So while the queue is not empty, the size of our queue is going to be just the length, and then I'm going to create this current level, which is going to contain the sum of our nodes at that level, right? So we're going to keep adding to this current, we're going to keep adding to this current level variable here as we loop and keep considering nodes. So the way we're going to do that is we're going to use this size variable that we defined earlier for I in the range size, right? Size is what's controlling how many nodes are at that level. So what we're going to do here is we're going to say current node equals q.pop, and I think we're popping off from, yes. So we're going to pop off from our queue, and we're going to add to this current level the current node dot value, right? And then if our node has any children, then we would append to our queue those children, right? So if our node has a left child, let's append it. Similarly, if our node has a right child, we'll also append it. And here, when this loop finishes, right, that means we've gone through every node at that level. We're finished with the current level. So now what we can do is we can say level average is equal to current level divided by our size, right? What that means is, just like earlier how we saw like the second level was, I think, 15 and 20, it would be 15 plus 20 is kept within current level, and then we would divide by the size, which is 2. I think it was actually 20 and 9, but it doesn't really matter. The point is, when this loop finishes, we'll calculate the average, and then we'll also append to some result, right? So we need a result, so I'm going to go ahead and create a result here. And this is going to contain the averages of all of the levels. So level average. And when this finishes out of this loop, here we should just be able to return the result. So hopefully this works. Let's run this. Okay, this didn't work. 13 and a half. Oh, it's close. So something is a little bit off here. I think this is supposed to be 0. There we go. So the reason that worked, and that was the fix, is because the order in which we pop from our queue matters, right? Here, what I was doing, let me zoom in a little bit. Okay. If you don't put 0, pop on a list in Python is just going to pop from the back. We actually want to pop from the front, right? We want to pop in the order that things were placed into our list, right? Because that's the point of a queue. It's first in, then first out. This pop was acting more like a stack. So let's go ahead and submit this. Great, and that works. So in terms of, let's talk about runtime and space complexity, right? So for our solution here, we're doing a level order traversal, and that's a BFS. So how long does a BFS take to run? Well, that's going to be an O of edges plus vertices, right? You can think about it that way, but it's going to go through all of our nodes. So we have n nodes. So I think this BFS takes O of n time. I might be mistaken here, but I think it is O of n considering all of the nodes. And then we're using a queue to maintain our tree, and it's going to keep up our whole tree, right, overall, because although we're popping from our queue, we're going to continuously append node values to it, and eventually, not eventually, it's going to take on every single node in our tree. So I think that's also an O of n in terms of space, but again, like, please feel free to fact check here. But yeah, this is a working solution. I hope this helps, and stay tuned for the next problem.